I've been working for the last few weeks on LTSPICE 15. It's a circuit simulator. I've been trying to make a circuit and simulate it using audio wave files. So what I'm doing is I'm taking a design which is out there at the moment and changing values. As you can see, this circuit is based on Zen Drive, and what I'm doing is testing it. Now I can actually get a waveform from this quite easily by running a waveform test. I can change some components here. For example, this R4 250K, that is actually the drive of the circuit, and it goes up to a maximum of 500K. It's normally on a pot, but I've put it to half drive, so it's 250K. But I can alter the value of that resistor there and see what the output is using the oscilloscope, built-in oscilloscope, which is on this program. And what I've actually done today, I've managed to use a wave file of a guitar, acoustic guitar, playing just a little sequence, and I've managed to use this command, as you can see, or these two commands, in order to input the wave file here, and then at the output, the circuit, I can actually download that onto a wave file at the output and actually hear what this schematic sounds like, which is fantastic, really. So not only can I design something, see how it performs on the oscilloscope, but I can also test what it actually sounds like, which I didn't think that was possible till recently. But let's just all I have to do now is I have to just run the simulation, and if you've seen these commands on the screen, you can use the same. It takes a little while to run this simulation. You can see here all of these values within here I can actually change and rerun the simulation and see what the pedal sounds like with the changes, which is tremendous, really. So this is Zen Driver circuit diagram, and I'm just using it as an example, but I'm actually going to be designing my very own pedal with pretty much as unique as I can circuitry on it, because it's something I've been wanting to do for a while. I'm going to be designing a reverb pedal as well, analog reverb, and probably some sort of flanger pedal and other things in the future as well, and using them for myself, but probably later on, if they're good enough, releasing them under the Delatronics name. I've already bought metal boxes and a few components to actually do this with, so this is a project that I've got on the sideline at the moment. I'm going back to repairing as well, servicing, so that will happen in Brazil, obviously, but I've got to wait till my leg is sorted out first, because I've still got problems with it at the moment, so I'm going to wait until they sort my leg out. So there we are then, it's done the simulation. So all I need to do is take the oscilloscope probe in this thing, put it on the output to see what the output looks like, and it will actually draw what the output wave looks like. When I've been messing about with these designs, these schematics here, I've been just looking at the waveform and seeing from the waveform in my mind what it sounds like. But as I say, I've recently discovered this waveform thing. So what you would do now is you would go to your files and you would go to out.wave, because that's what I specified it as. If I double click that, right, so as you can hear, that is the output wave after it's been processed by the effect. Now if I come out of this, I'll play the original waveform, and hopefully you can hear a difference. There we go. There we are. So hopefully with YouTube and all that, they really do compress the data, so all the pictures are awful. They come out well in the video, but then when I look at the videos I've uploaded to YouTube, they look really grainy and horrible, so they don't take any details. And I know that this as well, this computer screen is going to look very flickery as well, but that's just filming for you and YouTube and all that. But anyway, hopefully you can get an idea of the difference, and the fact that, you know, once it's gone through this circuit that I've got here, I'll just expand that again. Once it goes through all of this, I've got biasing here. This biases this point here at half voltage, so that the input going in here is in the non-inverting part of the amplifier. It's biased to be at a level of half the VCC, which is half of 9 volts, 4.5 volts. So the signal that's coming in is floating on 4.5 volts, so it doesn't clip against the rails. Sorry if this sounds like, you know, gobbledygook to people, but some people might understand what I'm saying. Distortion resistor, or potentiometer as that should be, is always on the negative feedback loop, and the higher this resistance is, the higher the distortion is. Here in this design you've got some MOSFETs. I had to, LTSPICE didn't have this model of MOSFET, so I had to, it's taken me weeks to be honest with you. I had to actually remodel that and import it into the library. And there we go. You see, I've had to do that there. Also, this particular op-amp I'm using in here, TL081, again, LTSPICE doesn't have that model there, so I've had to go through and remodel the TL081. So yeah, it's been fun and games. See, and there's the output. So what you can do on here is, if you want to see what it sounds like at different gains on the graph, you can actually put a sort of a command here, SPICE directive here, and you can actually get it so that these change, and you can see the results at different different readings. So I can make this here, which looks like a resistor, but it's actually a pot. I can actually make this a variable resistor, varying from whatever I want in whatever steps I want. And I can see what it looks like on the graph at different stages. But because I'm putting this wave file in, which is guitarchords.wav, I've named it. I downloaded this wave file from the internet. There are sites where you can download standard wave files. What I've tried to do as well, I've tried to record a wave file of me saying testing 1 2 3 on my phone, converting that into a wave file from with a special application and loading it in here, but for some reason it's not working. So it's probably something to do with the phone, the way the phone is converting it into a wave file is not being recognized. It's very, very finicky, this LTSPICE, but the difference between LTSPICE and PSPICE is this LTSPICE is free, absolutely free. It took me probably about 2 or 3 days to know how to put the schematics in, all the symbols in. So it's not that difficult initially, but then when you get into you know, changing a voltage source into a generator, generating a sine wave, and then now with the WAV files, there is a lot to learn, and it's taken me a while to do it, much trial and error, but I've got it working now, as you can see. So yeah, I hope you enjoyed this video, and hopefully there'll be more videos in the future regarding this. If you've got any questions, just ask them, and I'll try and answer them as best as I can.